How's it going, guys? It's going off grid, and today we got another Chinese inverter. Something I am known for having, mostly because I'm just intrigued by all the different designs, and some work, some don't work, some last a long time, some blow up within a couple hours. Just like playing the lottery. Anyways, on the inside I noticed it's got a similar design to Reliable's older 8000 watt. I don't know if their 6 and 5000 was like this, but their 8000 was. They got the input board, so all the inputs are on one side. Sorry about that. All your input FETs, everything's at the bottom, and then it just sent up straight up to the top board through this wire and this wire here. Those probably are quite high voltage. Anyways, so it's got the split board. The upper side is all the output, the filtering, the pure sine wave side, all that. And so this one all of a sudden started acting funny. We were on vacation, we were boondocking, me and a buddy. This was in his setup. I have a 3000 watt Reliable in my setup. We both run air conditioners off our inverters, and this one was working fine for the longest time. And it did have a nice surge, like it could easily push 3000 watts, and it seemed to be doing pretty good. And then one day, they thought they overloaded it or something. And then from that point on, it could only do like 1500 watts or 1000 watts, or not even that much. It was like hit and miss big time. And so luckily I had a extra Reliable inverter in my trailer, and so we swapped out. So now it's actually the 8000 watt Reliable I repaired years and years ago that he's got in there. So he's got a big freaking inverter in there right now. It no longer does the 8000 watts anymore. I think there was some damaged components inside. I was only able to fix some of it. The traces got damaged and whatnot. So I think it pushes about 4000 watts now, where before it pushed closer to 7. And now he's got that in the trailer, but I'm sure he'd like to get this one back. This one at least, well, it hasn't been repaired yet. So I was looking through it. No damaged MOSFETs anywhere. All the MOSFETs look good. All the fuses are good. I'm wondering, what the heck is going on here? Like, what would cause this thing to go? Or at least not go completely, like even these MOSFETs here. Let's see if we can see them here. There's nothing wrong with it. Anyways, I can't move this around too much. The wires are very limited. It looks like they had an afterthought and put a current sensor on. It's something at least. So, after I checked all the fuses, I'm looking around, I'm like, man, this thing looks fine on the inside. There's no burny smell, no magic smoke, no nothing. Other than some hodgepodge stuff like this. It's not a super clean looking board, but it's okay, as long as it works. And then, I was just looking around, and then I noticed this. Holy smokes, look at that. This was in an RV, so it looks like it came loose and it was arcing here to here. The nut almost fell right off. That's crazy. Wonder if this was spinning. Oh. Yeah, so this thing, I'm gonna have to tighten that from here to here first. And then I'm gonna tighten this up, and we're gonna see if this thing will push at least over 3000 watts. I don't want to go close to 4000 because it's a Chinese inverter. And a fella I used to watch on YouTube, old time engineer, good fella. His rule of thumb with Chinese inverters, 70%. You use 70% of their output and they last you a long time. He had really good luck. I've had really good luck using the same rule. So if you use that rule, you'll probably have good luck. Because there's been 2 of us now that's had pretty good luck with it. But if you overload them all the time, they will pop. They just don't have quite as good safeties, I've found. It has some really high-end American-made or North American-made equipment. But yeah, look at that. I think I found the problem. There you go, Chris. I get you back your inverter. One more thing I want to say. I've never seen this before, but because they cheaped out so much on the main heatsink for all the FETs here, they put little tiny heat sinks on the opposite side. I wonder how well that would work. Like, that would help with hot spots and the FETs. Very, very interesting. But I really don't like this. This is hilariously small. Like, hilariously small. It's literally like 1.25 inches tall by like 3/8 thick. That's the whole heat sink, and there's one on the other side, same thing. And yeah, I think this thing's gonna work now. Tighten that thing up real good. So we're gonna check the positive side to make sure that's not loose. Okay, now we got the inverter back together. We're gonna try it out and see if it makes power. Okay, so we're about to hook up this 48 volt 5 kilowatts usable batteries to the inverter. We're going to see if it's any good, but before that I'm going to make sure that I use my load, which I'm going to use for the inverter. I'm going to use it as a resistor and put this between my last terminal, the negative on the battery, to the negative on the booster cable, which is hooked to my inverter. And I'm going to do that just to charge capacitors so I don't get a huge spark, and there's a high chance of blowing a BMS every time you do this if you don't use the resistor. Okay, we're all hooked up. Let's see if it works. Now last time we tried this, it wouldn't even run 1500 watts. So let's see what happens. It ran about 1000 watts. The second one went to 1500. It stopped. Okay, it's on. Your voltage is at almost 58. Our output voltage is 116. Oh boy, the bugs are coming. Let's try low first. No problem with low. No problem with high. Look at that, guys. I'm going to go ahead and call this baby fixed. That's awesome. There you go, Chris. Easy fix. At least there was no MOSFETs we had to replace.